So hello everyone and welcome to this next lecture in the DC-DC converter series, and this is where we had left off in the previous lecture where we were simulating the transformer. So we had come across the waveform of the transformer currents and the transformer voltages, and we had simulated a high frequency transformer, that is a 10,000 Hertz transformer supplied by a 10,000 Hertz source. So this is where we had left off. Now in this section, or rather this lecture, we will get started with how we can actually start using transformers in isolated DC to DC converters. So the first obvious choice will be a flyback converter. So we will gradually get started with that. Now, before I start, as usual, a little bit of brief background that if you're interested in these kind of video lectures, but you would like something a little more comprehensive, I have a full-length online course on the MOOC website Udemy. The first course which I have is called Simulating Power Electronic Circuits Using Python, and in this I talk about the basics of Python power electronics, how to install software, some basics of circuit theory, and finally there is a tutorial on simulating a buck converter. If you are interested more on the digital signal processing side, I have another course which is called Basics of Digital Signal Processing for Power Engineers, and in this I talk about the basics of signal processing, how signal processing can be performed using Python packages, and finally there is a case study of how you can design a low pass and a notch filter using frequency response characteristics with Python packages such as NumPy and SciPy. And the latest course which I have is called Simulation of Magnetics for Power Electronics Using Python, and in this I talk about how we can some basics of magnetics applied to power electronics, simulating an inductor, a coupled inductor, and transformers. And finally there is a case study of how to simulate a flyback converter. So the links for these courses are provided in the video, the description of this video, so do check it out if you're interested. So coming back to the topic. So before we get started with the new simulation, what I would like to do is I would like to export all my parameters. So I go to Edit Circuit Parameters, and just click on the export button in all cases. So the exporting is usually good because then we can always copy all the CSV files over to a new directory and get started again with the latest parameters. If we do not export, we might be ending up with some old parameters which might be a little outdated. And now that we've exported the circuit parameters, we can now export the control parameters, or rather the parameters of the model of the transformer. So with this we are done. We can go back to the main page. So what I would do, I will go over to my file browser and create a new directory, and let's call this flyback converter, though we won't jump onto a flyback right away, but we'll meander a little. So this is my flyback converter. Let me go copy all my files. So I'll go secondary load, transformer model, two winding transformer, voltage source. And I copy all of them. So all I have to do, as always, pick out the path because I'll need it when I create a new simulation. And let's go over to create simulation. So I'm going to call this flyback converter, and let's just copy it. For now, since we've already started with the other one, let's keep it at 1e raised to minus 9 because this is where we had left off the previous one also. And here I will paste. Let me go back and let me copy the path again. Okay, and let's add the file. So let's just get started exactly where we had left off. So first we take the voltage source, save it, choose the transformer, and eventually the load. Alright, and of course we can click on process circuit schematics, but this is already a working simulation, so I don't expect any errors, and there are none. So we have now got started exactly where we were. So there are a few changes which we need to make. So let's just go to the edit circuit parameters and let's check out the circuits first. So the voltage source, this is the voltage source that we have. What we have so far is an AC voltage, right, that is applied to the primary of the winding. Now in a flyback converter, it is a DC to DC converter. So this voltage source will have to be changed to a DC voltage source, right? Now let's go back again. The transformer will stay the same, and I will talk about there'll be one major change in this transformer. That change will be in the polarity, right? All the polarities, if you look at a flyback transformer, you will notice that the polarity of the dot polarity of the primary and the secondary are the opposite. So in a flyback transformer, the primary winding will have a dot on the lower winding or lower terminal, and the secondary will have a dot on the upper terminal. This is typically how it is because the flyback is that kind of transformer, but we won't start it right away. We'll go to that gradually. So the transformer circuit is still the same, and finally there is a load. In the load, we will make one change. We'll get rid of this inductor because it's a DC to DC converter. We do not need an inductor, right? Or we can make it negligible, but I would just get rid of it. So with this, let's go and import everything. So let's upload the file. And there is the inductor, no problem. In the beginning, I would just say back up everything, and then let's go ahead and change it. These are the parameter files. And the last is the voltage source. And this is our voltage source. So let's go and make those changes that we did. I'm going to close all these files because these are from the old flyback transformer. We don't want to be changing this. Instead, I will go and open the files that I've just created. So let's start from the beginning. That is the voltage source. Then comes the two winding transformer. And then comes the secondary load. Alright, so the first change I'm going to make is I'm going to get rid of this inductor. I'm going to put a wire element. And let me see what other changes I need to make. Let's check out the source voltage. The source voltage is only a parameter change because all I have to do is change this. There will be another change that will come later, right? So in the source voltage, what we have to do is we have to now introduce a switch. So let me put some columns here and put a couple of columns, same here, wire. Let me introduce a switch element. So let's call this switch S1. Alright, so this is switch S1, which we're now going to control. This is a change in the voltage source. So let's go and check out what other changes need to be made. We already changed the secondary load, the two winding transformer. For now, let us not change any of the polarities. Everything remains the same. We'll talk about the need for a polarity change very soon. So with this, let's go over back to the main page, and we need to process because we have added another component, we have removed a component. So the circuit does not have any detectable error, so we are good to go. Now let's change it. Here let's just confirm that our inductor is gone. Yes, it is. So we're good to go. In the voltage source, we now have to go and give the switch a control name. So let me go over and change this rating to 1000 volts, equivalent to all the other stiff elements. The negative polarity. Now, where will be the negative polarity? Let's go over to the circuit. Now, we want the negative polarity or the cathode to be pointing towards the right. Now again, this is just a convention. The reason for this convention is because this is a DC voltage source and we are assuming the polarity of the DC voltage source to have a positive terminal upwards, which means that the current will always flow to the right. And if the current has to flow to the right, then in this case the switch has to have a cathode polarity towards the right, because the switch will conduct current in only one direction. So this polarity is okay. Now the control name, let's give it a better name. Let's call this switch gate, S1 gate, right? Save the parameters and we are good to go. Now in the voltage source, we've already made the change. Now all we have to do is we now have to edit our control file. Actually, let me just go and verify whether the transformer parameters have changed. Yes, the transformer parameters have changed, so we are okay. So we need to upload our transformer model. So this is the transformer model. And let's upload the descriptor file. And with this, we have all the control variables. So we're good to go. Now, what we need to do is we now have to add a gate signal for our switch. So for that, all I will do, let me go over to my control file and let me just go to any of the other controls that I have. Like for example, I have gate signal. So this gate signal needs to be copied from any of the other files to this one. So like for example, this is a transformer model. So let me compress this and take the flyback converter. So this is the new file. I will copy this gate signal from boost converter to the flyback converter. Let me go over to my file browser. Check out boost converter, gate signal and gate signal descriptor. Copy them. And go to flyback converter and let me paste it, right? So let's come over here. We should be able to see the gate signal now here. So let me open both the control files. So this is my gate signal. So now that I have this gate signal, let me upload it in my simulation. And let me call this PWM, save it. Let me configure it by uploading the descriptor. Alright, the only thing which I need to do is I need to make sure that this is indeed my switch and the switch is the same, right? Because I have same output target switch S1, the rest are the same, right? So this is good to go. We can use it right away. If, however, you have changed it, you are of course welcome to change this name also. For example, we can always delete it and add a new control output. So for example, I can just say desired name can be S1 gate, initial value can be 0. This is sometimes the case because when you move your simulations when you move control files from one simulation to the other, sometimes the device names will change and therefore there can be a mismatch between the actual device and the control file. If that is the case, just delete and rename them. And the same with the control inputs. So you might need to hook these up again. Now, with this, let's go back to the main page and we now have a fully set up circuit simulator. So let me just bring this back to point 3 and we are good to go. So first step is, let me go and run the simulation, make sure there are no errors. We will not analyze the results because, as I said, that will take a little more time. Let's go to the command line, check if there is an error. There is no error. So we do have a basic working simulation, right? So with this, I'm going to stop this lecture now because, as I said, I don't want to get these lectures too long. So in the next lecture, we are going to talk about how to take the next step forward. That is, how to take this very basic topology that we have created, a very basic topology that we've created of a DC to DC, of a DC source. Actually, we have to change that and we have to convert the DC source to an actual output DC voltage through a modulation, right? So let me actually go over and change that. By the way, I have forgotten to change that. So this is my voltage source. This is no longer 311 volts. This has a zero peak, zero frequency, and instead it has a DC offset of, let's say, 24 volts. So let's say we are trying to change the value of a 24 volt DC battery, right? Save the parameters. And now that we have this, let's just go back and run it again, just in case. Make sure it's working. Just for safety, let's just plot a voltage. Probably doesn't mean much, but let's say we can. So this is V input, save the waveform, and let's click on V load, V output. Again, a repeat, this is not a functioning. I don't know how this got created. Let me delete it. Somehow this was a glitch. I'm not sure what happened. But anyway, this is now my voltage. So let me plot it. And we see that it is at least working, right? Now, in the next lecture, we'll talk about why this is not done. This is not a DC to DC converter. We have to make several changes before we get to a flyback converter. And there are several conceptual problems that we need to solve in order to be able to create a working DC to DC converter with isolation. Because most importantly, we have to deal with the energy stored in the transformer. So with this, I will end this lecture. As before, if you have any doubts, feel free to message me on social media, comment on the video, or send me an email, whichever is your preference. Otherwise, I will see you next week where we will continue with the simulation. Thank you so much for watching. See you soon. Goodbye for now.